Hello.
Yes, yes.
Sir, Anjali ma'am sent me some document regarding tool, I guess.
Okay, okay. Tool, I
He
think tool
told
will start. Tool will start, I think so. Tool will
tomorrow.
start. I don't
Okay.
have information. Maybe, maybe ma'am will schedule the class. Schedule the
Okay.
class. Okay. Okay. So we completed with digital. Today we'll start the unlock part. So today I will explain you about the basic means basic semiconductor physics and electronics. So basically we'll see about the semiconductor physics. So basically, what is electronics? Electronics is nothing but like in engineering, there are so many branches, no? Computer science, mechanical, electrical, and this electronics. So electronics is nothing but that is a branch of engineering which deal with current conduction through the vacuum. Okay, so before 1947, before 1947, we used this vacuum tubes. No, so before 1947, we used vacuum tubes. Okay, so the current conduction through vacuums, okay, and gas or vacuum or gas or semiconductor is known as electronics. Okay, electronics that is essentially we deal with electronic devices and their utilization. Okay, so basically we'll deal with these electronic devices and their utilization. So in electronic devices, current flow through a vacuum or a gas or semiconductor. Okay, they have some specific properties are there. That properties that behave as a friend of man today. So basically, due to this electronics only, we are using whatever the electronic gadgets like mobile phones, TVs, refrigerators. Okay, all these are user friendly. User friendly. Those are there. Okay, so this is the electronics. And next, what is the importance of electronics? I think you already studied in your BTech, like rectification. What is rectification? The conversion of AC into pulsating DC is the rectification. No? So there you studied like half wave rectifier, full wave rectifier, and a bridge rectifier. So that means in order to develop a power supply, okay, the power supply there is some step down transformers and rectifiers and filters, and next you have regulators. Okay, so there is some block diagram will be there. So basically if we want to convert AC to DC, we are using this rectification. Okay, and next amplification. Okay, my voice is audible, no? Your response? Hello.
Yes,
Yes,
audible.
sir.
Yeah, yeah. Next is amplification. Amplification is nothing but like if you want to increase the amplitude of the signal, okay, if you want to increase the amplitude of the signal, we are using amplifiers. So there also we are using transistors for amplification. Suppose if you see one example, like in an auditorium, some means suppose within a students are like 10 trainees are like maximum 20 trainers, he can means the trainer who is
Sir, your voice is
giving
breaking.
the one second, one second. With it fine, your response.
Yes, sir.
Okay, it's breaking or no, it's fine.
Now it's fine, sir.
Okay, okay. So, so what happens? So it means the trainees they can listen their voice. Suppose within an auditorium, some thousand or 2000 or 10,000 audience are there. Okay, so means the speaker who is speaking, he can't. So the audience can't listen the voice. So there he need to speak in the mic. So mic what it will do? It will convert a sound signal into like electrical signals. Again, you are giving to some box that is nothing but amplifier. This will amplify that signal. Again, it is given to the speaker. Speaker will convert electrical signal into sound signal. So there we can use the amplifiers. Okay, amplification. Okay, and in communication also we are using in order to amplify the signals. Okay, we are using this amplification. And control means what? Control means we are using in automatic control in the refrigerators or ACs. We are using this electronic devices for automatic control. Okay, and for generation also. Generation means if you want to convert a DC power to AC power. Okay, basically you have oscillators. Okay, basically you have the oscillator that will generate the AC power. Okay, those are nothing but DC to AC generators. And next you have conversion of light into electricity. Where you will use this light into electricity? In your home, LED TVs are there, no? LED TVs. LED TVs, this will convert whatever the light in, not LED TVs, light into electricity means solar, solar panels. Okay, solar panel, through the solar, we are generating the uh, solar panel. Through the solar panel, we are generating the electricity. Okay, so there, whatever the sunlight is there, you are converting into electricity. Okay, so whatever the electronic device that will convert light into electricity, that is nothing but like you have the solar example is for solar panels only. And conversion of this electricity into light. Electricity into light means so basically you have LED displays and LED bulbs also coming. LED bulbs, okay, and normal tubes, okay. So this will convert whatever the electrical energy into uh, one second. Yeah. So it will convert electrical energy into light energy. Okay. So these are the applications of electronics. Okay. Any doubt in this? One is rectification. Next one is amplification. Next one is control. Next one is generation. Generation from DC power to AC power. And conversion of light into electricity. Conversion of
Sir,
electricity
can you
into light.
explain this control?
Basically, control means if you consider control means if you consider refrigerator, refrigerator. Okay, in the refrigerator, what you are doing like if you want to set the temperature. Suppose if you want more cooling, so outside there will be some buttons. If you press the buttons, so based on that buttons, if you decrease the temperature, inside that will be temperature will be decreased. No?
Yes.
That is control. Suppose in a refrigerator, suppose in refrigerator, sorry, in ACs, if you see ACs, suppose if you want more cooling means what you will do from the remote, you will decrease the temperature so that based on that outside there will be an actuator. That means the outside there will be a what we call compressor. No? Compressor fan will move more fast so
Yes.
that your room temperature will decrease. Okay, that is nothing but control. And suppose printer is there, printer. So you are giving the signal from the your computer to the printer. So what the printer is doing, some
It is
mechanism will be there,
printing.
no? Yeah, it's printing.
Yes.
Inside, some different types of printers are there, like inkjet printer. Inside, some motors are there, no? Inside, some motors are there. So that is nothing but it is rotating motor control. Or you can design remote control car also. Simple design means remote control car. You can control the direction of the car based on your remote switches. Okay, that is automatic control. Robots, drones. Okay, in this all
Yes, sir.
fields we are using this control. Okay, so control electronics, we are using electronics. Okay, so nowadays drone technology is coming. No? Drones means they are like if you take Russia and this other countries there, no. So they are using the drones to attack in the other country. Okay, so they are sending the drones and they are making to explosion as the explosion, and they are damaging the countries. Okay, like that. They can use drones in the militaries. Nowadays, robotic army also coming. Robotic army means what? With the help of robots, they are making the army. And so what happens if a robot is damaged means nothing will happen. No, just they will get some loss, but life will not go. No, understood. So these are the different controls we are using. And in the satellite also, we are sending the satellite to the orbital, okay, or we are sending some other rovers in the other planet to see the either whether water is available or not, to see the property of that planet. So that is based on total control. So electronics is based on this control. Okay, so from the Earth they are controlling that rover in the other planet with some signals. Or do you understand?
Yes.
Okay. So this is about the importance of electronics in our day-to-day life. From day one onwards, you are using electronics. Like from when you like when you wake up, what you will see? Anyone tell me?
Clock.
Uh-huh. You are seeing clock. Huh? You'll see mobile, no?
Phone.
You'll see mobile, no?
Yes, sir.
You are seeing mobile for any notifications you got, any WhatsApp or any messages you got. So that means from day one onwards you are using electronics, no? So that is based on the electronics only, no? The mobile is based on the electronics only. Yes, means either you want to see the time, you are seeing in the mobile only. So from day one onwards, you are using whatever the electronics like refrigerator to store the vegetables. You are using refrigerator to see the. But you want any entertainment, you are watching TV. Okay. In the summer, if you want more comfort, you are using ACs like that. Household applications and office applications. All these are the electronics only. Yes. Shall I move forward?
Yes, sir.
Okay. Next you see. So next. Okay. First, about we'll see this atomic structure. Okay, basically, any suppose according to the modern theory, matter is electrical in nature. If you take any matter, that is what electrical in nature. Okay, matter is electrical in nature, and here, if you see, all materials are composed of very small particles called what? Atoms. Okay. So, what are the basic building blocks of matters? So, those are nothing but atoms. Okay. Basically, like you have electrons, protons, and neutrons. After that, with the help of this electrons, protons, and neutrons, you have atoms. With the combination of atoms, you have molecules. In the combination of molecules, you have matter. Okay. So, whatever these atoms are there, atoms are the building blocks of matter. Building blocks of matter. Okay. So atom consists of what? So you need to study about that atom. Okay. I think in chemistry or physics during this intermediate you studied about it. But in order to understand the semiconductor physics, I am coming from the basics itself. Okay. Just should try to listen. So it consists of central nucleus of positive charge. Okay, around the small negatively charged particles called electrons will revolve in different orbits. Okay, so nucleus. What is nucleus? It is the central part of atom, contains protons and neutrons. So what is the atomic weight? Number of protons plus number of neutrons is nothing but atomic weight. Okay, there will be extra nucleus outside. In that electrons will revolve around the nucleus. Okay, so this you know. Okay, so this is the basic atomic structure. So if you see, any matter is made up of what? Atoms. Atoms are made up of molecule is made up of atoms. Okay, and particle is made up of molecules. Okay,
Molecule.
okay. So if you see, central part is what? Nucleus, and there will be orbital around the nucleus. Electrons will flow. So in the nucleus, what will be there? neutrons and protons. Neutrons doesn't have any charge. These are neutrons. Neutrons doesn't have any charge. Protons have a charge, positive charge. Protons. You have protons. Okay. And around this, electrons will revolve. Electrons will revolve. Okay. This is about the atomic structure. Do you understood? Hello.
Yes, sir.
Yes.
Okay. Okay. Now, if you see, the atomic number is nothing but what? The number of protons or number of electrons. Okay. So, there is some orbital. There is some orbital. Okay. Suppose number of electrons in any orbital is given by 2n square. Okay, 2n square. Suppose first orbit, if you see, so first orbit is nothing but 2 into 1 square. How many atoms? How many electrons? 2 electrons will be there. In second orbital, 2
Eight.
into 2 square. 2 into 2 square means 8 electrons. And in third orbital, 2 into 3 square. How many electrons? 18 electrons. Okay, each and every orbital have how many number of electrons means given by this formula. Okay, last orbital cannot have 8 electrons. Okay, last but one cannot have more than 8 electrons. Okay, this is nothing but we can call as octet, octet or stable condition. Okay, stable state. Okay, so this is about the atomic structure. Okay, uh, so if you see the carbon atom, what is the atomic number for carbon? Can anyone say? Huh? Carbon.
Six.
6. 6 means what? 6 means here in the first orbital you have 2 electrons. In the second orbital you have how many electrons?
Four
4
electrons.
electrons. Okay. So that means this is first orbital. This is like this is a stable state only. We can't do anything with this. Anything if you want to do, we can do with this one only. Okay. 4. 4 we can do. Okay. All the electrical and physical and chemical properties are depends on this 4 electrons. Okay. So see here. So inside this nucleus, there are protons and neutrons. This blue color are there, no protons, and this black color are nothing but neutrons. And first orbital have 2 electrons, and second orbital have how many electrons? This dotted are there, no? This dotted. These are how many electrons? 4 electrons are there. Okay. This is the atomic structure of what? Carbon atom. Yes. Your response. Shall I move forward?
Sir.
Yes,
Okay.
sir.
Okay. Next you see. Suppose if you take the copper atom, copper is metal or non-metal?
Metal,
Copper
sir.
is a metal. Copper is a metal. Okay. So
Metal.
what is the atomic number? Atomic number is 29. Atomic weight is nothing but what? Number of protons and number of electrons. Atomic weight is 64. Okay. Basically number of protons are 29 and number of neutrons are 35. So basically 29 plus 35. This is the atomic weight. So how much you are getting? 64 you are getting. This is atomic weight. Number of atomic number is equal to what? Number of protons, that is equal to number of electrons. So that means how many number of protons are there? 29 protons are there. And how many number of electrons are there? 29 electrons are there. Okay. So this is first orbital, second orbital, third orbital, and fourth orbital. Okay. So 29. So you can write like this. So that means 2, 8, 18, and last orbital have how many electrons? 1 electron. Okay. See here. 1 second. Okay. Yeah, see here. So that means see here. First orbital have how many electrons? 2 electrons. Second orbital have 8 electrons. Third orbital have 18 electrons. And fourth orbital have how many electrons? 1 electron. So by applying external energy or external source, we can easily remove this electron. We can easily remove this electron. Okay. So that's why copper is a good conductor, or this is the responsible for electricity. This electron is responsible for the electricity. Okay. So just I am explaining with the copper atom. Okay. So next if you see. So good metal. Okay, we can call as a good metal and a good conductor. Okay, and next if you see what is the charge of the electron, you know. Okay, 1.6 into 10 power minus 19 coulomb, and mass of the electron is 9 into 10 power minus 13, and the radius of the electron is 1.9 into 10 power minus 5 meters. Okay, very tiny particle, that is nothing but electron. Okay, what is the energy of electron? There are two types of energies are available on the electron. One is
And potential.
kinetic energy and potential energy. Okay, so kinetic energy is due to what? Kinetic energy is due to what? Motion.
Okay.
Kinetic energy is due to what? Motion. Okay, and motion of the electron. Potential energy is due to what? Charge on the nucleus. Okay, so like you can ask, electron is revolving around the nucleus. Why electron is not falling on the nucleus? Why? Because there are two types of energies available on the electron and neutron. Electron, those are nothing but kinetic energy and potential energy. So kinetic energy is due to motion, and potential energy is due to charge on the nucleus. Means nucleus will pull the electron. Okay, both are equal. So that total energy is sum of two energies. Okay, you can correlate with the planets also. Planets are revolving around the sun. No, you have 9 planets. No, 9 planets in a solar system. So 9 planets are revolving around the sun. So why planets are not falling on the sun? So for the planet, there are two types of energies are available. Those are nothing but kinetic energy and potential energy. Kinetic energy is due to what? That motion, and potential energy is due to what? Due to charge on the planet through the sun. Okay. Due to this, both are total energy sum of these two, so that it will revolve around the sun. Okay. Same like that, electrons will revolve around the nucleus. Okay. As energy increases, okay, energy increases as distance from the nucleus increases. This potential energy and kinetic energy is there, no? That increases as you increase distance from the nucleus. Okay. So we can say that electrons in the last orbit have high energy compared to the electrons in the inner orbit. Okay. So last orbit, I told you, know, carbon. Carbon means what? 2, comma 4. Okay. We can't do anything with this. This is stable only. Anything electrical or physical or chemical property we can do with this only. Okay. So the last orbit electron play a major important role in determining the physical, chemical or electrical properties of the material. Okay, that last orbital plays a important role. Okay, is it fine? Shall I move forward?
Yes, sir.
Yes.
Okay, yeah. Next, if you see, next valence electron. Valence electron is nothing but what? Valence electron is nothing but the electron present in the outermost orbit of atom is nothing but valence electron. So we already seen the carbon atom. So carbon atom have how many valence electrons? Carbon atom have how many valence electrons? Four valence
Full.
electrons, no? Four valence
Four.
electrons. Four. On the basis of electrical conductivity, materials are generally classified as what? Conductors, insulators, and semiconductors.
Semiconductor.
Okay. Yes. So if you see, that means you have a periodic table, no? You have a periodic table. You already studied
Yes.
periodic table in
Yes.
chemistry. So suppose this is the basic reference. Suppose valence electrons is 4. Okay. So if you move this side, conductivity decreases. Conductivity decreases. So conductivity decreases means basically these are we can call as 1 second. Conductivity
Matter.
increases. Sorry, conductivity increases. Conductivity increases. So conductivity increases. These are nothing but basically we call as metals.
Metals.
Okay. Copper is there. Copper having the valency of how much? 1, no?
20. One.
One.
That
Valence is
One. One.
valency
one.
1. 1. 1 means what? This is related to group 1. Okay. It is related to group 1. So as you go this conductivity increases and these are metals. As you go this side, conductivity, what happens to conductivity? Conductivity decreases. Okay. So conductivity, 1 second. conductivity decreases. Okay. Okay, conductivity decreases. Decreases. Okay, 1 second. Yeah, conductivity decreases, and these are nothing but non-metals. These are nothing but what? Non-metals. Okay, and if you have the valency 4, these are nothing but what? Metalloids. Metalloids means what? It is having the property of both conductor and non-conductor. Okay, or insulators. Okay,
Metal and
so metalloids we call as metalloids, or we can call as semiconductors. Okay, basically semiconductors. Okay, so see here. So sodium is a metal or non-metal? It is having the valency of how much? 1, 2,
One.
sorry, 2, 8, 1. So how much is the valency? 1. So sodium you can call as metal. Magnesium. Magnesium have the valency of how much? Magnesium have the valency of how much?
2.
2. So magnesium have the valency of 2. Okay. So this is also we call as metal. Okay. Aluminum have the valency of 3. Okay. So aluminum have the valency of 3. So this is also metal. Aluminum is metal, no? Basically we are using for high tension wires. Okay. Aluminum is cheap. That's why we are using for high tension wires. But outside there will be poles and high tension wires are there. There we are using aluminum. Okay. These are all metals. Okay. If you go left side to the periodic table, those are nothing but metals. Okay. And if you go right side, suppose nitrogen is there. Nitrogen having the valency of how much? 2, 4, so 2, and next
5.
5. Okay. 5. Valency is 5. This is gas, no? Nitrogen is gas, no? Sulfur. Sulfur having the valency of 2, 8, and next 6. 6 is
6.
also non-metal. 6 is also non-metal. Okay. And neon is inert gas. Basically, this what are the inert gases? The helium, neon, argon, krypton. These are the inert gases, stable gases. So this is having the valency of how much? 2, 8. Okay.
8.
In your stable configuration. Okay. So when the valency of electron is more than 4, usually those are nothing but what? Non-metals and insulators. Example, nitrogen, sulfur, neon, these are non-metals. Okay. Now, see here, what are the metalloids? Carbon. Carbon is like it is having the valency 4. Carbon having the valency 4. Silicon.
4.
Silicon is how much valency? 2, 8, 4. Exactly 4.
4.
And germanium. Germanium have the valency of how much? 2, 2, 8, 18, and 4. 32 is the atomic number, and basically this is 4. So basically these are we can call as
4.
what? Semiconductors. These are nothing but what? Semiconductors. Okay, semiconductors, which is having the valency of how much? Valency of 4. Okay.
4.
If it is less than 4 means those are metals. More than 4 means those are non-metals or
Non-metal.
insulators. Exactly 4 means those are nothing but metalloids. Okay. Now our study is based on what? Semiconductors. Okay. So now if you see this free electron means, suppose if you consider these are the free electrons of copper atom. So basically, what happens? These are randomly moved. Okay, randomly moved. Suppose when current is flowing, it will be moved. It will be moving with a particular direction. When you apply some external voltage or external supply, it will move with a particular direction. Okay, so this is nothing but about the free electron. Okay, and types of materials, if you see, I told conductors, insulators, and semiconductors. So
Semiconductor.
conductors have what? Those are having the more free electrons like copper, aluminum, and gold, silver. Okay, gold, silver. Okay, these all are nothing but metals. Insulators doesn't have the free electrons at ordinary temperature. Tell me some examples of insulator. glass, wood, okay, plastic. These are insulators, okay. And semiconductors means very few electrons, free electrons are there at room temperature. Consequently, under influence of some potential difference, semiconductor practically some current conducts in the semiconductor. Okay, so that we will see what is this. Okay, and next, these are the types of materials. Now you see there is a Bohr's atomic model. What is Bohr's atomic model? In 1913, Niels Bohr, a Danish physicist, given a clear explanation of this atomic structure. Okay, so he told that atom consists of what, a positively charged nucleus. In the nucleus, neutrons and protons are available, and electron will revolve around the nucleus. Okay, and electrons are revolved in a permitted orbit or fixed orbit. Greater the energy of electron and larger the radius. Okay, suppose if you apply some external energy for the electron, okay, what this electron will do? Electron will lifted to the higher orbit. Okay, electron will be lifted to the higher orbit. That is said to be, we can call as the state of excitation. After some time, it will come to its normal state. Okay, so this is. I think you already studied about this Bohr's model, no? Yeah, Bohr's atomic model.
Yes, sir. Yes, sir.
Bohr's atomic model in chemistry we studied. Okay, basically it shows the like he given the atomic model based on the solar system only. Like planets are revolving around the sun, no? Like this,
Electrons
electrons are
moving.
revolving around the nucleus at permitted orbit. Okay, different types of orbits are there. Okay, suppose example of carbon is there. Carbon having the valency how much? Carbon. Carbon have the atomic number of how much? 14. 14 means, so suppose first second orbit have K shell, L shell and M shell. K shell, L shell and M shell. In K shell you have 2 electrons, L shell you have 8 electrons and M shell you have 18 electrons. Okay. So here what happens, which at a first orbit, second orbit and third orbit you have what, radius. Different types of radius are there. R1, R2, R3. Different types of radius. They move with a fixed amount of energy. Okay. If you see the example of carbon. Okay. So next, if you see here, we get the concept. Suppose these energy levels, suppose convenient way of representing energy at different orbit is shown below. Suppose these are nothing but radius. Suppose we can call this radius as what, energy level, second energy level, or third energy level. We can call this. Okay. So, but in the carbon, there should means we don't have only one carbon atom. No? Suppose if you take one molecule, how many carbon atoms you have? So many, some millions of carbon atoms are there. Okay, so that means from the nucleus to this orbital, we call as what, if there are group of carbon atoms, if some lakhs of carbon atoms are there, so we'll represent only one carbon atom means we'll represent like energy level, first energy level, second energy level, third energy level, like this. Some lakhs of carbon atoms are there, we represent as energy bands. What we call energy bands. Okay, first energy band, second energy band, and third energy band, like that. Okay, so carbon atom is having the valency how much? 14. 14 means here first energy band is 2, second energy band is 8. We can't do anything with these two energy bands. Last energy band is, this is nothing but we call as valence band. What is called? This is nothing but valence band. So here these are already stable. One second. What happened to my PPT? One second. Yeah. So here we are concentrating only on which band? The last band, that is nothing but valence band. Okay, valence band, valence band. So important energy bands in the solids. One is what? Valence band. What is the valence band? This is the range of energy which valence electrons are there. That is nothing but valence band. Okay, so here, see here. So that means here, if you see the carbon atom, so before that there are bands are there. Band first band have 2, and second band have 8, and third band have 4. Third band have 4. Okay, so that is valence band. And next you have conduction band. Conduction band is nothing but whatever the loosely attached electrons are there, free electrons are there, those are nothing but valence band. Okay, so valence electrons are loosely attached to the nucleus. So I told you, for copper atom, if you apply some amount of energy, it will excite from this atom to some other state. Okay, some other state. One second. One second. Okay. Okay. సరే ఓకే ఓకే మళ్ళీ ఏమైంది ఇండికేటర్ వస్తలేవా సరే సరే ఓకే సో conduction band is nothing but what? Conduction band is free electrons are available in this band, we call as condition band. And forbidden energy is nothing but the distance between valence band and conduction band, that we call as forbidden energy band. Okay, the electrons are not present in this valence band and forbidden energy gap. Either electrons will be available in the valence band or electrons will be available in the conduction band. Okay, did you understood about this one? Your response?
Yes,
What
sir.
is valence band? What is conduction band? What is forbidden energy gap? Okay, the energy gap. So energy gap means how much of energy is required to move the electron from valence band to conduction band is nothing but we call as forbidden energy gap. Okay, so basically valence band. Okay, valence band is nothing but what? Low energy level band. Okay, this is associated with what? Valence electrons, free electrons. Okay, so whatever the electrons present in the valence band, those are associated with the atomic structure. Those are associated with the atomic structure. Okay, so when the electrons present in the valence band, they will not participate in the current flow. Suppose electrons are present in the valence band, they will not participate in the current flow. Okay, and conduction band. So what is this conduction band? Conduction band is nothing but higher energy band, we call as higher energy band. In this, free electrons are available. Free electrons are available in the conduction band. That means when the electrons are present in the conduction band, these are not associated with the atomic structure. They can freely move. Okay, they can participate in the current. Suppose copper atom is there. So copper atom means that one atom should jump from valence band to conduction band. Then only the conduction takes place. Okay, by
Sir, your
applying
voice is
extra.
breaking.
1 second. 1 second. Now it's audible. Your response?
Yes, sir. Yes.
Okay.
Yes, sir.
Okay. Okay. That is conduction band and valence band. Next, basically what happens means here, so silicon atom is there. Silicon atom. Silicon atom have the how much of valency? Silicon atom. What is the atomic number for silicon?
14.
14. 14. So that means 2, comma 8, comma 4.
4.
4. This is the valence. So total you have valence electron. Okay. So what happens? Every atom in our universe, it will try to acquire the stable condition. So what happens? There are like you already studied covalent bond, ionic bond. Covalent bond is nothing but sharing of electrons. No, covalent bond is nothing but what?
Yes.
Sharing of electrons. So
Sharing
what
of
happens? Sharing of electrons. Suppose this silicon atom, what it will do? It will do. Some more silicon atoms are there. So this will talk to this. So I want to share one electron from you. Okay, like that it will talk to each and every silicon atom, and so this will these remaining silicon atom will accept, and this will take part in covalent bond sharing of electrons. It makes stable configuration. This is nothing but what? Stable configuration. Okay. So like that, it will make a crystal, silicon crystal. We call as a silicon crystal. Okay. So basically, what happens? This called a silicon crystal. Uh, so what happens during room temperature? Suppose during 0 Kelvin, these are acting as a 0 Kelvin. These are acting like insulators only. These are acting like an insulator only. At room temperature, what is room temperature? At 300 Kelvin. Okay, at 300 Kelvin, what happens? That means 200 degrees Celsius. Okay, so what happens? This way, this electron is there. No, electron will break this covalent bond, break this bond, and make it free. Okay, make it free, and this will be jump from valence band to conduction band. Some amount of conduction is there in the room temperature. For semiconductor, some amount of free electrons are available in the conduction band, but not that much conduction. Some amount of conduction is there in the semiconductors. Okay, so this is energy band in the materials. So basically, classification of materials, if you see, so basically conductors, semiconductors, and insulators. Conductors have high conductivity, like uh, conductors. This forbidden energy gap is overlapping. There is no forbidden energy gap. Okay, so sigma is greater than 10 power 7. This is high conductivity, and sigma and resistivity are reciprocal with each other. So rho equal to 10 power minus 7, like copper and aluminium. And insulator, if you see, more energy band. This 6 electron volt energy is required to jump the electron from valence band to conduction band. So low conductivity, so less than 10 power minus 10. High resistivity, more than 10 power 10, like mica and wood. Okay, and these semiconductors have the forbidden energy gap is how much? 1.1 for silicon. 1.1 for silicon. Moderate conductivity is there. That means 10 power 4 to 10 power minus 6 conductivity, and moderate resistivity will be there. 10 power minus 4 to 10 power 6. Basically, silicon and germanium are nothing but semiconductors. Did you understood the difference between conductor, semiconductor, and insulator?
So,
Okay. The silicon atom we'll see tomorrow. Okay. So today we discussed about basic physics and basic semiconductors and how the energy band diagrams and are there. Okay. If you have any doubt, you can ask me. Otherwise, we'll stop.